All right, in this example, we're looking to see whether or not these three vectors are linearly independent in R3. So what that statement's really saying is, can you write C1 V1 plus C2 V2 plus C3 V3 is equal to 0? So you're trying to find out if you can find constants such that these each have to equal 0. Okay. So if we look at the augmented matrix that's forming this V1 is here. It's 2, 1, 0. So you can see that this is 2, 1, 0. This is 3, 3, 0. And this is negative 1, 2, 0. And those would be columns vectors of C2, C3. That's what we'll be multiplying by. And we're looking to see if it satisfies this equation. Okay. So if you notice, if you look at the coefficient matrix A here, okay, if you pay particular attention to the diagonal elements here, it looks like we have two diagonal elements here, but this B3 forms, if this is B3, this is an elementary matrix. Okay, it would be an elementary, not matrix, I said elementary matrix. Sorry, an elementary vector, but B3 is not. That's what we're looking for, but B3 is not this. Okay, so B3 is not an elementary vector, which means that, well, you can see it here. You have a row of zeros. So at most, that these three sets of vectors, it could give you maybe a plane. So like an R2 sort of situation, but there's no way that you could add a linear combination of these together to get any of the three components for a vector in R3. Okay. All right. So we're going to go ahead. So that's the first part of this. So it is not linearly independent set of vectors. They are linearly dependent. Another way to see this is the second part of this problem, which was asking us, I believe, to do something about finding it as a system of linear equations. Okay. So you can kind of see that we've already set that up here. I'm going to take the augmented matrix of the A matrix with and use row reduce. So solving a system. I'm having a hard time spelling, apparently, system with augmented matrix. So we have, well, it's going to be a little tight, but that's right. 3, negative 1. 1, 3, 2, 0, 0, 0. Okay. So if I want to reduce this, I'm going to multiply this by 2 and multiply row 2 by negative 2 and add that to row 1. Right now, row 1 is not changing. This is going to be 0. And then negative 2, that's negative 6 plus 3 makes that a negative 3. Negative 3 times negative 2. Yeah. Negative 2 times negative 1 makes that a positive 2. 2 plus 2 makes that 4. And that'll be 0. And of course, the bottom row is still zeros. Let's see, did I do that right? Negative 2 times row 2. All right, negative 2 times, that's what was confusing. Okay, so negative 2, that's negative 2 plus 2 is 0. Negative 3 times 2, no, sorry, negative 2 times 3 is negative 6 plus 3. Is that a negative 3? That's negative 4 plus 1. Negative makes that a negative 5. Okay. All right, so that does change it a little bit. Okay, so that makes that a negative 5. Okay, and it looks like I can add row 1 to row 2 for the next one. So the row of zeros won't change. Looks like the row 2 won't change. And first element won't change. Adding these together, you're going to get 0. Negative 5 plus a negative 1 makes that a negative 6 at 0. Okay. So now we have it in our two pivot elements here and here. Okay, so that's a -3. So I can write this as 2c1 minus 6c3 equals 0. And then I have -3c 2 minus 5c3 equals 0. And of course, that one doesn't give us anything. So solving this for c1, you get c1. You get c1 is equal to adding 6 over and then dividing by 3. You get 3c3. And that means that c2, if I add the -5 over, it's going to be equal to a -5 halves, no 5/3, c3. Adding 5 divided by -3 makes that a negative. Yep. Okay. So it looks like c1 can be written as 3c3. C2 is -5/3 C3, and C3 is C3. Okay, so if we let C3 equal, let's say, a number, I feel like 3 might be a good number. Yeah, let's try 3 and see if that works. Okay, so that means that so this means that C1, C2, C3 would equal, so C1 would be equal to 9, C2 would be equal to -5, and C3 would equal to 3. Okay, so let's check to see if those constants will work for our system and yield our desired result. Okay, so C1 is 9 times 210 plus, I have a -5, and that was 330, and then plus, and then I believe it was 3, -120. Okay, so we should end up with a 0 vector here. So this is 18 minus 15 minus 3. This is 9 minus 15 plus 6. And then 0 plus 0 plus 0. This equals 0. This equals 0. And this equals 0. Hey, look at that. All right. Well, we found our 3 constants. Those are not the only ones. Obviously, the choice of C3 is arbitrary, so there's infinitely many of them. We just found an example of one that works. Okay, so I hope that was helpful, and I'll see you in the next video.